What's up geeks, and welcome to the channel. Imagine we're biologists who need to analyze a long DNA sequence. In this example, DNA sequences are represented as strings containing the characters A, C, G, and T. Our task is to find all the 10-letter long DNA sequences that occur more than once. In other words, given a string, we need to identify all 10-letter substrings that appear at least twice in that string. To visualize this, take the string we see as an example. The output would consist of two strings, both of which are repeated twice in the initial string. Now, the first solution that comes to mind is to identify all possible 10-letter substrings in the initial string. Then we group these substrings by occurrences. Any substring that occurs more than once is a valid answer. To group these substrings by occurrences, the first structure that comes to mind is maps. The 10-letter substring will be the key, and the value stored will be the number of occurrences. So, given a map in which we store our substrings and their respective occurrences, what we return is the list of keys stored in this map that have a value strictly greater than 1. In this implementation, we do this with the help of Java streams and the filter method. Now, to actually populate this map, we will need to iterate over every possible 10-letter substring in that string and store the substring as a key in the map. If that key already exists, then we retrieve its value instead and increment it by 1. This solution works. However, to improve its efficiency, we can use two sets, one to store scene substrings and another to store duplicates directly. This approach avoids the overhead of updating counts in a hash map and simplifies the logic, allowing us to directly count and identify duplicates. So, if we start off with two sets instead of one map, one of these sets will store all the repeated 10-letter substrings in it. This will allow us to immediately return this set back since it is our final solution. Now, to loop over the possible 10-letter substrings, we will make use of the same exact for loop we previously had. The extraction of the substrings will be exactly the same as before as well. The main difference lies in the checks we do. So, we will add every possible substring in the seen set. When this substring is seen again, then we will proceed by adding it to the duplicate set. You see, we don't actually care if it was seen 2, 3, or more times. All we care about is if it was seen once or more than once, regardless of the actual count. So, after the loop ends, the scene set will contain all possible 10-letter substrings extracted from the initial string, and the duplicate set will only contain the ones occurring more than once. And that's it for this video. I hope it was helpful. Thank you guys for watching, take care, and I will see you in the next one.